Uh, Good morning to all of you. And in the we are almost in the uh, com- towards the completion of this what you call the synthetic theory of evolution. In the last class, we have studied a lot about gene flow and genetic drift and all those things. How that helps in the process of evolution in the modern day. Now, all these things which we have studied is based on the modern inputs or the new inputs or the especially the inputs from biochemistry, genetics, cytology, molecular biology, and based on that we are able to discuss about this synthetic theory of evolution. After having studied and discussed the factors which bring the variation, which helps in the process of evolution. In the end, again, we will be studying the role of natural selection in evolution. We started our discussion with the natural selection as one force or as one factor which is responsible for the evolution. And now we are again in the end discussing about the natural selection. This natural selection is a key factor for evolution, which all of us agree. So, the evolution by natural selection, as I have told you, that involves both chance and sorting. One is the evolution is a mere chance, and natural selection selects. And at the same time, natural selection also sort among the hundreds or thousands of variation presented to the nature. Nature will sort only few. So, as a result of this, new genetic variation arises by chance. New genetic variation arises by chance in the sense, now again you have to recollect what we have discussed during the mutation, both chromosomal as well as the gene mutation. Then this mutation will add more and more variations to the population. And genetically also, the beneficial alleles out of all the variations, all only few may be having certain adaptive value. Others may not have any value, or sometimes many variations may have nuisance value also. But the nature will sort the beneficial allele, and those selected beneficial alleles are favored by the natural selection. So that's why natural selection continuously as well as consistently results in adaptive evolution. Adaptive evolution, in fact, evolution to happen and to continue, they should have the adaptive. Otherwise, nature will not select. So ultimately, we can say that natural selection brings about adaptive evolution. Natural selection mainly acts on the organism's phenotype by the external morphology or external feature. The natural selection brings about the adaptive evolution, and it acts on the physical characteristic and selects it. We have, while in the beginning, while studying the natural selection, we have also come across a term struggle for existence and survival of the fittest. Now, after having studied the synthetic theory of evolution, this struggle for existence and survival of the fittest appears to be more crude and misleading, because by hearing these two terms, we always expect there's a competition among the individuals. And in the competition, only the fittest will survive. That's what we understood. First, there will be a competition, that is the struggle. Struggle means you are fighting between for their very existence, and that follows the survival of the fittest, of course. But now we know that it struggle for existence or the survival of the fittest means it is the reproductive success, which is more subtle and depends on many factors. In order to carry forward any of the variations, any of the characters, it should those organisms possessing those characters should be able to reproduce. They should have maximum reproductive success so that in the next generation the offsprings will have more of such variation. And it is at a very subtle level, and the reproductive success of an organism is not depending on either the physical strength or its mental strength or anything, but it depends on very many factors. There are so many factors which contribute to the reproductive success of an organism. So, a relative fitness. So, we are talking about the relative fitness. If the contribution of an individual makes to the gene pool of the next generation relative to the contribution of other individuals. This is what we call the relative individuals. What do you mean by that? Say, in a population, there are 100 individuals. Say, for example, out of that, all 100 will not produce same number of offsprings in the next generation. Out of this 100, there may be few which produce more number of offspring. There may be few which produces less number of offsprings. There may be few which produces in between that, and there may be few individuals which may not reproduce at all. Now, the relative fitness refers to the contribution of an individual that contribute to the gene pool of the next generation. Suppose if there are 100 individuals, out of that, probably one individual will contribute, will produce more number of offspring. Naturally, the next generation gene pool will have more number of such genes contributed by that individual compared to the other individual. So that is the relative fitness. In other words, an individual which can produce more number of fertile offsprings, that fitness is known as relative fitness. It is always in comparison with others. If one produces more offspring, naturally that will contribute more to the gene pool of the next generation compared to other individuals. So the a selection favors certain genotypes by acting on the phenotype of certain organism. Natural selection favors certain genotype, but natural selection will not act directly on the genotype, but it will acting on the phenotype of the organism which are having certain specific genotypes. So thus, the genes are also contributed to the next generation or gene pool of the next generation. That's what. Now, in the selection, there are different types. Natural selection. It can be directional, disruptive, or stabilized. There are three more. What do you mean by that? Directional selection. Directional selection refers to it favors the individual at one end of the phenotypic range. It contributes or it favors the individual at one end of the phenotypic range. Only one extreme character, a phenotype, an extreme phenotype may be selected. The next one is disruptive selection. It favors the individual at both extremes of the phenotype. One extreme at the right side, another extreme at the left side. Both are selected, not the intermediates. Whereas the stabilizing selection, it favors the intermediate variants, and this type of selection acts against extreme phenotypes. To give one example, directional selection. Suppose a human being takes birth with a horn on his head. With a horn on his head, it's a new trait. If the natural selection, this is an extreme range, it's an extreme type of phenotype. If the directional selection, if the natural selection selects such types, that is known as directional selection because at one end of the extreme type. Whereas disruptive selection favor the individual at both the extremes. A person having a horn as well as a tail. Two extreme, it favors both, one having head, both the and the one having tail also it will select. But stabilizing selection favors the intermediate varieties, the one which is not having either horn or tail. This is or what you call the stabilizing selection. See here the phenotype. This is the original population. You can see frequency of the individual. See here the phenotype per color with the original population. Now, if in this population, if the directional selection operates means the original population, it is an evolved population. It selects the organism in only this only at one end. These two are eliminated. They are not selected, and in the next generation they are not found. This is what you call directional selection. Disruptive selection. See here, the original population. Here also it is selected one extreme end, and on the another extreme end also it is selected. It is selecting only this and this, and these three, one which are of the intermediate characters, they do not have any chance. This is the disruptive. In stabilizing selection, see, it will select the most intermediate type. It will eliminate all the extremes at both the ends and favors only the most intermediate type. So the original selection, the evolved selection, evolved population, the directional. This is the disruptive. This and this are preferred. The intermediates are not preferred. And here, in stabilizing, only the intermediate one are preferred. Both the extremes are eliminated. Now, what is the relation between natural selection and adaptation? And how this favors the evolution? It has been observed in nature that sometimes there will be striking adaptations have all of a sudden arisen by the natural selection. Just you recollect what I have told in the last classes. Nature is a dynamic entity. It is fluidic. It is not constant or static. When the nature changes, if the organisms living in this nature, if they have to survive, means they should adapt to the nature. Nature will select only those organisms which are adapted to it. When the nature changes, if the population has to survive, means along with the changes of the nature, the population should also change. For this change, we use the word evolution, evolve. That means there must be some striking adaptations should appear in the population, and it should be selected by the natural selection because of the virtue of having more adaptive value. So, a good example for striking adaptation, cuttlefishes. Cuttlefishes can change color rapidly for camouflage. Cuttlefishes or squids, what we call, they have the ability to change their color with the change in their background or environment. Because of having this adaptation, they are not easily spotted by the predator because they blend. The color of the cuttlefish blends with the color of the nature or its background. This is an adaptation. So cuttlefishes have survived and evolved. Even for example, the jaws of snakes allow them to swallow prey larger than their heads. All of you have seen the snake head is such a small head, but they can swallow. A python can swallow a deer also. How? The jaws have striking adaptation. It can swallow the prey 3 times larger than their head. In most of the fish snakes, and in some it is much more larger. In case of the python and all. See, this is the here there is a small change in the ligament. The bones shown in the this is the green area. They are movable. See here. When these ligaments are attached, the snakes can open their mouth up to this. So naturally, anything which is smaller than this can be swallowed. Anything which is smaller than this can be swallowed. But in snakes, it has taken another adaptation. See, the ligaments get detached. This and as a result, the mouth can open and it can swallow even a larger egg which is larger than the size of its head. This is an adaptation. And nature selected this adaptation. So, as a result of this, all snakes are having this type of arrangement. In the end, in the summary, we may say that natural selection increases the frequency of only those alleles that enhance the survival and reproduction of the individual. Natural selection increases the frequency of those alleles which are responsible for or which increases the survival value of the individual as well as the reproductive fitness of the individual. That is the role played by the natural selection. And any adaptive evolution occurs as the match between an organism and its environment increases. What do you mean by this? An adaptive evolution occurs and seen and visible. Suppose if the intimacy between the organism and environment is more. If an organism is closely associated with environment means the intimacy will be more and adaptive evolution can happen instantly as the environment changes because it becomes very difficult for the organism to survive. So for that somehow some noticeable changes it will develop and that becomes the adaptive evolution. All of us know that environment is changing continuously. When the environment is changing continuously, the adaptive evolution is also a continuous process. As and when the environment changes, the adaptive evolution also should. Otherwise, if the environment changes are very slow, means even the evolution process will also slowly follow the change of the environment and always try to adapt to the nature to the best of its efforts possible. All of us know that genetic drift and genetic flow do not always lead in its environment. Sometimes it can increase the match between the organism and environment, sometimes decrease that intimacy. So that's why uh, we can say that genetic drift and genetic flow, gene flow, they do not consistently lead to adaptive evolution. Sometimes it can contribute to adaptive evolution, no doubt, because it can increase the attachment between the organism and environment or decrease. Both things are possible. In natural selection, most important one is the sexual selection, because sexual reproduction brings the maximum variation because of the recombination. So that's why sexual selection is a natural selection. In order to carry out sexual reproduction, first thing is to identify the compatible mate, and sexual selection favors the mate success. It can result in sexual dimorphism, marked difference between the sexes in the secondary sexual characteristics. Male and female are distinct, where you can where they can easily identify. It's a part of the sexual selection. See, take the example of peacock and peahen. Peacock is brightly colored, brilliantly colored, very dancing, agile, but female dull, no feathers, much the feathers, no paraphernalia for that, no fancy item. Male is beautiful here. Why? The sexual dimorphism. And this is the sexual selection. Why do the males have such a plumage? It is in order to attract the female. Female is attracted by the male's fancy. So that's why they have this thing. In this sexual selection, there are two types. One is intrasexual selection. There may be competition among the individuals of one sex for the mate of the opposite sex. Usually, competition is often among the males. Males will fight. May not be physically sometimes. Here, I can give you the example of the weaver bird, which bring the nest, which build the nest. Male bird build the nest. So many male birds start building the nest in order to attract the female. There's a competition in building the nest, in the architecture, in the uh, fineness, in fine tuning the nests. Once the nest is ready, female will visit all the nests. And if there are 100 nests offered to it by 100 males, it will select one nest and mate with that male. and remaining 99 has to discard their old nest and start building new nest in an anticipation of getting another female. This is the competition. Whereas another type is intersexual selection, mate choice. It also occurs in the individuals of one sex, usually the female. They are choosing selecting their mates. All of you might have heard the calls given by the bullfrog during the early rainy season. Melodious call given by the male frogs. Have you heard? They will sit on the water bodies, sit on the bank of the water bodies and give melodious calls to the females. It may not be melodious for you, but certainly it is melodious for the females. The call is for the female frogs, not for the human beings. So, uh, then there will be so many calls from the members of the same species, but the female will select only one bullfrog based on the amplitude, frequency, pitch of the call and mate with that. This is intersexual selection. Usually, the male chauvinist, it is due to the mate choice can increase the male chance of attracting the female. See, the beautiful fancy feathers of the peacock is associated with the mate choice. Female will select only those males, which are having which can showcase their beauty by spreading the feathers, dancing, wagging. Certainly, that increases the reproductive success of that individual male because it will be able to pass its genes to the next generation. But it will also decrease the chance of the survival in the sense when the male is having that much fancy showiness, they are easily attracted by the predators also, not only by the opposite sex, even by the predators. They have a good chance to or good chance of reproductive fitness. At the same time, they may have a decreased chance of survival also. But they don't care whether they survive or not. Their main intention is to enhance their reproductive fitness. So that's why they develop all this showiness. Then, okay, this is for the male genes. But how do female preferences to evolve? The good gene hypothesis suggests that if a trait is related to male health, both the male trait and female preference for the trait should increase the frequency. What do you mean by good gene hypothesis? All traits are because of genes. A, a trait that is related to male health, if you consider that, both the male trait, a male having very good health, and female preference for that trait, then it should increase the frequency of that gene. Hope you are confused. Think that there are so many characters in a male, and male health is one such character, and it's the male trait, a very good robust health. Male prefers that, undoubtedly. Even the same trait is preferred by the female means the same trait is preferred by female, then the trait has more chance to contribute to the future generation. That is, it should increase in the frequency of those traits in the next generation or future generation. That is the good gene. The good genes, if they are preferred by both the male and female, then the frequency of that gene increases in the next population. Suppose if the male has a good gene for health and female prefer only chauvinist means, then which gene will perpetuate? The one which is the individual which is having more chauvinist will be able to contribute more to the next generation, not the one which is having the better health. But if a good character, if it is preferred by both the male and female, then it has the maximum chance of contributing to the next generation. Then preservation of the genetic variation. There are many neutral variation, genetic variation. These neutral variations do not confer any advantage or disadvantage. They are there, they are past, they are continuing also sometimes, but they do not have any selective advantage or even disadvantage also. But then you may ask why this variation is there? Because in nature there are many various mechanisms which preserve the genetic variation in a population. We don't know at the given situation, this may be a neutral variation. But with the change condition of the nature, it may be a more preferred one that happens. So that's why the nature also prefer to preserve the genetic variation in a population with the help of various mechanisms. For example, diploid is one such mechanism. Maintain the genetic variation in the form of hidden recessive alleles. Hidden recessive alleles in diploid. Or heterozygotes carry recessive alleles that are hidden from the effects of selection because they are not expressed also. Unless they are phenotypic expression, nature will not select them. Heterozygotes can carry many recessive alleles that are hidden from the effect of selection. So that's why they are the neutral variants. They do not have any advantage or disadvantage. But nature wants to keep those variations alive. Then, talking about the balancing selection, a natural selection maintains stable frequencies of two or more phenotypic forms in a population. Don't be under the impression that natural selection will select only one character. No, it may select more stable frequencies of two or more phenotypic forms, two or more in a population. So that's why you take the example of human beings. All are, people are also there, medium size are also there, short are also there because they are all stable frequencies and balancing selection will select all of them. Balancing selection includes heterozygote advantage as well as frequency dependent selection. Heterozygote advantage, when the Heterozygotes have higher fitness than the homozygotes. If the heterozygotes, if they have more higher fitness compared to the homozygotes, that is what we call heterozygote advantage, and natural selection will tend to maintain two or more alleles at that locus. Take the example of sickle cell allele, which causes the mutation in hemoglobin. At the same time, it confers malaria resistance. So still then, so as a result, it is still in the population. See, frequency of sickle cell. In rest of the part, it is less. But if you come to this Africa where malaria is more prevalent, and this part of India also, see the percentage of the sickle cell will be more because sickle cell confer more resistance to malaria. That is heterozygote selection. Then another one is frequency dependent selection. Suppose if the fitness of a phenotype, if it becomes too common in a population, the fitness of the phenotype declines. If one character becomes too common in a population, then the fitness of a phenotype declines. Think that in a population, all are tall, all are tall. Then it has become a tallness has become a common, too common in a population. Then opposite sex will not select that. Because all are tall, there is no question of selecting them. If you select anyone, he is tall, or that organism is tall. So as a result, the fitness of that declines. Most of the time, the selection favors the phenotype that is less common in a population. Common traits are not preferred, but the traits which are less common, they are preferred, and that is selected. Frequency dependent selection selects approximately equal number of right mouth and left mouth scale eating fishes. See, not any one, this thing did the, see here, did the frequency of one particular fish, that is the scale eating fish, what we call. This is the left mouth and this is the right mouth. Just you observe the mouth. These two things are very common. So they have almost equal. Sometimes it will is more, sometimes this is less, more, less. So almost same it is. Equal number of right and left mouth one. After having discussed all these things, now you may ask why the natural selection can not bringing the perfect organism. All of you know there is no perfect organism as such. You take any individual, there are certain characters which are good, certain bad traits are also there. You may ask, when the natural selection is continuously operating, why can't the natural selection fashion out some perfect organism? Probably because of these four reasons, natural selection also fails to bring the perfect organism. One is natural selection can act only on existing variation. Natural selection cannot create variation and select. Whatever the variation there is existing, it will select the best variation. So the organisms which are selected by the nature are the best organisms, but not the perfect organism. Then the evolution is limited by historical constraints. So many genes we have lost in the history. So many variations we have lost in the history. Natural selection can operate only those variations which are at present. There may be some of the features must have been very nice if they existed even today, but not. They are not seen. The entire process of evolution is limited by historical constraints. Sometimes the adaptations often compromises. There must be compromise. There is no perfect adaptation as such. Even adaptations do make compromises because nature also depending on these individuals. When these adaptations can compromise to a certain extent, nature will not say that this particular organism should adapt to this much extent. No. If it adapts to certain extent, also the nature will allow them to survive. And natural selection is a chance. Environment should interact. There must be variation. Then by chance the nature should be able to select. All these things are there. It becomes a chance. So that's why I have told you natural selection can fashion out best organisms, not the perfect organism. There is no fancy word like perfection in natural selection, but the best. So, with this, I think I have completed our discussion on the synthetic theory of evolution. And uh, almost it took 5 hours for the synthetic theory of evolution. And I hope I have made every effort to convince it to you. One thing in the end, I would like to say you, whatever the diversity, the magnanimity of the diversity that we observe today is because of the evolution. Evolution is a continuous process. Mostly it is a slow process. Sometimes it may be abrupt also. But the natural selection is mostly slow process and it selects the best variation that is made available to it. And that is the reason for the magnanimity of all the organic diversity that we see. And that's the reason for the extinction of so many organisms in the remote past also. Why the dinosaurs have become extinct? You may give 101 claw reason, but to put it in one word, you can say that they failed to adapt or natural selection didn't didn't select them. That's one word. So, thank you all. Hope we too will evolve and we should. As far as the human beings are concerned, evolution is not only physical, it should be mental, spiritual, psychological, physiological, every respect we should be able to evolve because there's a struggle. The fitness should come from all direction. There should be a total fitness, complete fitness, physical, mental, psychological, physiological, and we are also evolving, and we should evolve, and that's the rule of the nature. So, thank you for your patient hearing. Uh, yes, now tell me, ಏನು ಗೊತ್ತಾ ಕೇಳ್ತಾ ಇತ್ತಾ ಕಾಣಿಸ್ತಾ ಇತ್ತಾ ಹಲೋ
Yes, sir.
uh, then what else? So then I will stop here and uh, wish you all a very happy Deepavali. Hope all of you will enjoy Deepavali. Yes? Anything else? Okay, if not, we will close it. Thank you for patiently. Meet you after Deepavali.